Evening, everyone. Now we are presenting to you our report on Chapter 2 Theory in the book of name Practical Electronics for Inventors, 4th edition. We are students in Group 2 of course Automobile, Electrical and Electronics Engineering. Here are names of our lecturer and group members. So let's get started with our first member, Nguyễn Đức Đạt.
Hi everybody, today I will be the first member to introduce you about the first chapter of the first part of the chapter 2. This chapter covers the basic concept of electronics, such as current, voltage, resistance, electric power, capacitance, and inductance. And this chapter also illustrates how to mathematically model current and voltage to and across basic electrical elements, as you can see on the screen. We move to the next. The definition is very simple. It's electric current. You have known it a long time ago, and this is the formula. And another simple definition is voltage. To get electrical current to flow from one point to another point, voltage must exist between 2 points, and a device that maintains a constant voltage is called a direct current voltage or DC voltage. And it had the mechanism of its mechanism, and voltage is represent the difference in potential energy. And we have the formula V between point A and point B is equal to the potential energy between point A and point B divided with Q. And the cleaner expression for the voltage is on the formula V equals U divided by Q. And the definition of phone and generalized power law is here you can see on the screen is 1 volt equal 1 joule over 1 coulomb, and the power is mathematically expressed as P equal dW over dt. And we move to the next is the combining battery. As you can see on the slide is if you want to get a larger voltage, you must place 2 batteries in series, so the voltage will be larger than 1 battery. Here is some other voltage source. This from the magnetic, the photovoltaic action, and the thermoelectric effect. It is so complicated, so it will be very helpful if you use water to explain electronics. We treat DC voltage as a water pump and wires like pipe, and conventional current flow like water flow. And a lot is just a network of stationary force. And the graph will help you to easier understand the voltage. And the last and another is resistance, resistivity, and conductivity. This is the history of Church Simon on published experimental results regarding the resistance of different materials, and this can be understood simply is that different materials have has the different resistance, and it is the um, it is the formula R equal V divided by I, and you can see it is a resistor, and you can uh, determine how much is it, how many resistance is that from its color is the color of the ring on this resistor. But now law isn't really a law. In fact, there are some material is actually doesn't work. And the last but not and another factor is how the shape of a conductor affect the resistance. As you know, there is a formula that R equal rho multiplied with L divide by A. When you increasing the resistance with length, when length is increased, the resistance is increased. And when you decrease the A, which is the cross-sectional area, the resistance will be decreased. And this is the explanation for the increase and decrease of resistance. And that is that will help you to understand why it occurs. And here is the picture, which is worse than 1,000 watts. See the resistivity of many material, and that is the formula that I mentioned before. And the last but not least is insulated conductor is semiconductor. The level of conductivity are the main difference between the conductor, semiconductor, and insulated conductor display high conductivity, and semiconductor it is moderate flow, and insulator is high but low conductivity. And this is the end of my presentation. And I will invite Hui to continue uh, to introduce you about the chapter 2.7 heat and power, which is the more crucial part. And thank you for listening.
Hello, teacher. My name is Wei Handukui, and my ID is 1914547. To continue the presentation update, I'm going to represent my group to present from 2.7 to 2.11. Now we start from 2.7 heat and watt power. As you can see that this is the generalized power laws. P equal I multiply B, and the generalized power laws tell us how much the power is pumped into the circuit, but doesn't say anything about how this power is used up. Now we consider the black box. The black box is an unknown circuit contain source of component like inductor, transistor, resistor, lamp, or motor, or something like that. Using ampere meter and voltmeter, we can apply the generalized power laws, multiply the current and the voltage. Together, we can get the power from into the circuit. Now we see if the black box is a perfect resistor, we can substitute volts into the generalized power equation. P equal V squared per R. In this form, the power loss due to heating is often called ohmic heating, Joule heating, or I square loss. For example, you see the black box that have P equal 1 and I square equal 0.01. So the resistor equal 100 ohm. Otherwise, we could say the black box is 100 ohm resistor generation 1 watt of heat. As you can see, this is erroneous assumption since we have disregarded the internal working of the black box. We didn't account the device that perform using work thermal heat conduction in thermal resistance. In this case, we find the answer. How is the energy transfer in heating? We have this in non-mental and this in term of mental. This is the table show that the typical thermal resistivity of some material, and this is the formula of P heat. Now we will talk about the importance of the heat production. Heat production represents power loss that the minimize whenever possible or at least taken into consider when selecting component. To avoid the problem associated with the heat production, we use the component that are rated to handle 2 to 3 or more times the maximum power they are expected to dissipate. For example, the limited number is written in the puff is smaller than the number that are expected to dissipate. And to reduce the heat, we can apply some passive method, include heat sinks, careful component layout, and ventilation. Or we can apply some active methods, include air fans, or some sort of liquid cooling. This is the picture of the CPU case. To reduce the heat of the CPU, they use the fans and the system of liquid cooling to reduce the heat of the CPU. Now we talk about why goals. There is a point where the current density can become so large that vibrating effect can overpower the copper electric binding energy, resulting in wear meltdown. To prevent this from occurring, it's important to select the appropriate wire size to anticipated current levels. This is the table show the copper wire specifications appear in animal coated wire. Ground. In the circuit, a point to be a kind of zero reference point on which to base all other voltage measurements. This point is often called the ground. We consider the earth ground. The definition of earth ground usually a connection terminated at rod driven into the earth to a depth of 8 feet or more. This earth ground rod, you can see that it's the first ground rod is quite directly to the main breaker box ground bar, to the ground bar of the breaker box, and sent to the various outlet, AC outlet, by the green coated or bare copper ground wire. Daisy house within the same main cable is hot and neutral wire. a common ground error, a common mistake for a novice to attain the power loss set and length using positive and ground terminal of supply. The correct product of course is either connect the plot between the positive and negative terminals directly, thus creating the float load, or using jumper wire between the ground in negative supply create ground load. A is wrong, B is wrong, and C is off. B is right and C is right. There is some different type of ground symbol. This is the popular symbol we usually use it. There is some loose end up on grounding with short hazard. Short hazard condition can create if the ground are neglected. Crowding and noise. Occur is when the lack of good grounding practice occur. Analog and digital ground. Device that combine analog and digital circuitry should, in general, have their analog and digital ground kept separate and eventually connected together at one single point. This is to prevent noise from being generated within the circuit due to the rail current. There's some trick to reduce the noise, like such as adding capacitor to counterbalance in induction. But a good trick to keep the digital and analog ground separated, then attack them at one single point.
My name is Ken. I will continue presentation. Electric circuits. Electric circuits is an interconnection of electrical components. An electrical circuit consists of battery, resistor, capacitor, transistor. An electrical network consists of closed loop is the path with electron from the voltage or current short flow. Electrical circuit can be classified as series circuits, parallel circuit, or combination of series and parallel paths. Next, we want to resistor and Ohm law. Resistor is a term used to decide reduction in current flow. In electronic circuit, resistors are very often connected in series or in parallel. Resistor in series. For the series connection, the current to each resistor is the same, and the equivalent resistor is equal to the sum of individual resistor. For a parallel connection, the voltage to each resistor is the same, and the inverse of equivalent resistance is equal to the sum of the inverse value of on parallel resistor. Next, we go on to Ohm law. The formula for Ohm law is voltage equal the current times resistor. This is relationship between current and voltage, and the relationship was discovered by German scientist Gale Simon Ohm. And next, the voltage and the current source. The voltage source. A voltage source is a two-terminal device whose voltage at any instant of the time is constant and independent of the current drawn from each such voltage shock is called the ideal voltage shock. It has a zero internal resistance, and the current source is an electronic circuit that delivers or short an electric current with independent of the voltage across. And there are two types, an independent current source deliver constant current, and dependent current source delivers current with proportional to some other voltage or current in circuits. We talk about measuring voltage, current, and resistance. We use the voltmeter, ammeter, and ohmmeter to measure the voltage, current, and resistance. The remester has a limitation that prevent them from make shortly after measurement. The convenient battery, the two battery network in the finger, so how to increase the supply voltage and or increase the supply current capacity. To increase the supply voltage, the battery are play into and in the series and terminal voltage of the battery add together to give a final supply voltage equal to the sum of battery. And the power delivered to the block can be found using power law, which V is the final supply voltage generated by on battery within the network. The open and the short circuits. The most common problem in circuit are open circuit and short. A short circuit implies that the two terminals are generally connected with resistance equal zero, the same as the ideal wire. This means they are zero voltage different of any current values. And an open circuit and a double circuit imply that the two terminal are generally disconnected, which is the equivalent to a resistance equal is resistance is infinite. This means that the zero current can flow between the two terminals and any voltage difference. The real voltage source had in a internal resistance and the conductor, so the maximum current fleet is reduced. However, there is usually too plenty of current variable to damage. This is my recent lesson. Thank you for your.
Okay, so I continue with Kirchhoff law. Kirchhoff law is a key for analyzing complex circuit, which cannot be analyzed using the simple methods. And we got two different Kirchhoff law, which is the voltage law and the current law. For the voltage law, you see the sum of the voltage around any loop is equal to zero, and for the current law, we have the total current enter junction is equal to the total current that leave the junction. Okay, let's see an example. here we have a very complex circuit, and assume that we have all the value of resistor here and the value of the battery voltage. What we have to determine is the current and the voltage unknown here. We have only 6 unknown is the current, because we can obtain the value of voltage after we obtain the value of current by using Ohm law. Okay, so we have to write 6 equations for 6 unknown for 6 unknown. So at junction A, we have here the current enter junction A is only I1, and there is 2 current that leave the junction, which is I2 and I3. And the same happened with junction B and C, but in Kirchhoff voltage law is different. Okay, for the voltage law, we have here the loop 1 start with the voltage of battery, which is V0, and after we know that after the current go through a resistor, it experience a voltage drop. So the current drop, the voltage drop here will get a negative sign, the same as I2 R2 and I5 R5. In loop 2, it's different, because we start here, we drop a voltage of minus I3 and R3, but the loop direction is contrast with the direction of the current, so we get the plus sign, because minus of minus E plus, the same as I2 and R2 here equals to 0. So we get 6 equation, and after calculation, we can obtain the value of all of the current here. You can use computer on determinant theorem in mathematics. After calculation, we have the result here. You can see. Okay, the Kirchhoff law is interest method to analyze circuit, but as you can see, it requires to deal with system of the equation with matrices, which is also complex. So we have to have some other method that is simpler to solve the circuit. Okay, so let's just continue. Here we have superposition theorem. The superposition theorem is the underlying mechanism of Thevenin theorem and Norton theorem, which we will consider later. Okay, so let's talk about superposition theorem first. Okay, we have the superposition theorem say that the current in a branch of linear circuit is equal to the sum of the current produced by X source, which the other source is said to be set equal to 0. The voltage source of the other is 0, which is this circuit. We can see that it have no voltage source, and as well as this circuit has no current source, which is broken from this circuit into 2 component circuit that is simpler, and we can treat these 2 component circuits as independent, and we write equation for them. Okay, like this, we obtain the partial current. After that, we obtain the real current by adding them together. Okay, so move on to Thevenin and Norton theorem. In Thevenin theorem, the man of name Thevenin is he's create a method which is much more simpler for us. That if we have only two terminal in interest, we can treat the other component of circuit like a black spot. Um, Thevenin consider them as a voltage source in series with resistance. Okay, so let's see how it's work. I don't like to read it. Okay, we have a real circuit here, here, and we apply Thevenin theorem here, and we remove this, remove the load R3 here, and consider this this circuit. We have we will obtain the value of V Thevenin here by Ohm law. We get a volt, and we obtain the R Thevenin here, which is 100 ohm. After that, we plug back the load here for the circuit to be closest, and we obtain the other value here. Okay, move on to Norton theorem. Norton theorem is similar to Thevenin theorem, but instead of consider a voltage source in series of the resistor, Norton is considered a voltage source in parallel with the resistor. Okay, here's how it works. First, we also remove the load R3 here and replace it with a short. Because of this shortage, there's no current go through R2 here, so we can get the current of Norton is I Norton is equal to V battery over R1, which is 0.01 ampere. And after that, we plug back the load R3 here again for the circuit to be closest and calculate like normal. Okay, I'm sorry. This is the end of my presentation. To continue, I'd like to invite the last member of our group, Hugh, to continue. Thank you.
Dear teacher and everyone, my name is Moving Hill, student ID 19145-179. Now I'm continuing the report of Group 2, Part 20, AC circuit. As we know, a circuit is a complex conductive part through which electrons flow from source load and back to the source. There are two types of source, direct current DC and alternating current AC. In DC circuit, electrons will flow in only one direction, resulting opposite with DC circuit. In an AC circuit, not only does the current change directionally, it's also voltage periodically reversed. And the AC circuit has an AC waveform. How to generate AC? The most common way to generate sinusoidal waveform is by electromagnetic induction by means of an AC generator or alternator. An axis Y positioned between the north and south poles of the magnet. As log rotates in magnetic field, the magnetic flux through it changes, and charges are forced through the wire, giving rise to effective voltage in induction voltage. The fundamental laws of electricity are mathematically complex, but Applying water as an analogy offers make it easier to get a basic understanding in AC circuits. We imagine that the flow in an AC circuit is just like water flowing back and forth within the house many times per second. Pulsating DC is a periodic current with change in value but never changes the direction. Some authors use the term pulsating DC to describe a signal consisting of one or more rectangular rather than sinusoidal pulse. DC is commonly produced from AC alternating current by a half-wave rectifier of a full-wave rectifier. We can combine sinusoidal source. Besides combining AC and DC voltage current, we can also combine separate AC voltage and current. Such combination on the screen is a result in complex waveform, for instance, to power low noise convert in simplicity. Powering device over the signal cable is a technique that is often used. Based on the generation method of AC current, we will get different types of waveforms, square, triangle, round, but commonly the sine waveform is most used. In an IC circuit, we focus on the period frequencies and the amplitude. It's also the volume to describe an AC waveform. T is the length of time in seconds that the waveform takes to repeat itself from start to finish. The frequency is the number of times the waveform repeats itself within a 1 second time period. In the A magnitude or intensity of signal waveform measured in volt or amp. AC and resistor, harvest voltage and current. The resistance only of resistance is both AC circuits in the same irrespective of the frequency of the AC supply voltage. The change in direction of current in AC supply does not affect resistor behavior. So the current in the resistor will rise and fall according to the voltage as it rise and fall. The voltage and current in AC resistive circuit reach maximum, then fall to zero and reach minimum at the same time. They are said to be in phase as they rise and fall exactly at the same time. RMS constant voltage. As you can see on the screen in the formula, and root mean square value, which is found by squaring the integral value of the AC voltage current, then calculating the limit, and finally taking the square root of this, which gives the effective value for the AC voltage and current. These effective values don't average out to zero, are essentially the AC equivalent of DC voltage and current. RMS values of AC voltage and current are based upon equating the values of AC and DC power required to hit a resistive element to exactly the same degree. The peak AC power required for this condition. Band power. Band electricity, also known by American English term utility power. Power with domestic power and war power in some part of Canada as high vol. The same in Vietnam. The voltage and frequency of electric power differ between regions. In much of the world, a voltage normally of 230 volts and frequency of 50 Hz. North America, the most common combination is 120 and 60 Hz. Here an example diagram of main power and ground supplying in America. we focusedly look at the whole supply system. The three wires from the pole rainbox transformer are connected to a watermeter, then enter a main circuit panel that is grounded to a long copper rod driven into the ground or to the steel in home foundation. A phase by A and B wires that enter the main panel are connected to a main disconnect breaker, while the neutral wire is connected to a terminal refer to as the neutral bar or neutral bar bus. Ground bar also may be present within the main circuit panel. The ground bar is connected to the ground port or the positive steel support. And if you want to supply power 140 volts by over water agency, you insert a double pole breaker between A phase and B phase first bar in the main or the panel. Next, take 240 volt 3-wire cable and attach one of its hot wire to the A phase terminal of the breaker and attach its other hot wire to the B phase terminal of the breaker. The ground wire, green color or bare, is connected to the ground bar. Then turn the cable where 240 volt rods are located and attach the wire to the corresponding terminal of the rod. The supply system in Vietnam is quite similar. In Vietnam, electrical system consists of power plant, power grid, and connected customer into a system to carry out the full process of production, transmission, distribution, and consumption electricity in the material. Operating voltage level on the Vietnam power system from 500 kilovolts to 230 kilovolts, 110 kilovolts to 35 kilovolts, 22 kilovolts, 10 kilovolts, 6 kilovolts, and finally the whole appliance 230 volts. Grid operating frequency 60 Hz. Structure of phase is 3-phase, 2-phase, or 1-phase. We usually use hydroelectric dam system to produce electricity. That's the all of our presentation. Thanks for listening.